This is the AP Statistics Quideo number 5 basic question. Here are the estimates of the daily intakes of calcium in milligrams for 38 women between the ages of 18 and 24 years who participated in a study of women's bone health. As you can see with the histogram, 0 to 300 has 0, 301 to 600 has 8, 601 to 900 has 12, 901 to 1200 has 9, 1201 to 1500 has 7, 1501 to 1800 has 0, 1801 to 2100 has 1, 2101 to 2400 has 0, and 2401 to 2700 has 1. The distribution of daily intakes of calcium is skewed to the right. For the mean, the sum of all the values is 35,189, and there are 38 values, so 35,189 divided by 38 is 926.026, and the standard deviation of the data it set is 427.2 milligrams. For the confidence interval, you have 926.026 plus or minus 2.042 times 427.2 over the square root of 38, and then you get 926.026 plus or minus 2.042 times 69.3, and then 926.026 plus 141.51, and then your confidence interval is 784.5 milligrams to 1,067.5 milligrams. If you eliminate the two largest values, the new sum of the values is 30,823, and there are 36 values, so 30,823 divided by 36 is 856.19, and the standard deviation is now 306.7. The difference between the means is 69.84 milligrams, and the difference between the standard deviations is 120.5. So the new confidence interval is 856.2 plus or minus 2.042 times 306.7 over the square root of 36, and then you get 856.2 plus or minus 2.042 times 51.1, and then you get 856.2 plus or minus 104.35, and your confidence interval is 751.9 to 960.5. And that concludes the basic question. And now for the advanced question. The two games are not independent because winning/losing the first game affects your chances of winning/losing the second game. The probability of losing both games is P 0.6 times 0.7, which equals 0.42, which is 42%. The probability of winning both games is P 0.4 times 0.2, which is 0.08, which equals 8%. X equals the number of games won, so for 0 it is 0.42, for 1 it is 0.5, and for 2 it is 0.08. The probability of winning just one game is 0.5 because the probability of all these events must equal 1. The expected value is 0 times 0.42 plus 1 times 0.5 plus 2 times 0.08, which equals 0.66, and the standard deviation is 0.62. And that is the advanced question for the Quideo number 5. And now for the AP question. Your parameter is the difference in the mean amount of E. coli bacteria detected by the two methods for this type of beef. For the hypotheses, the HO equals the mean difference, which equals 0, and the HA is the MD does not equal 0, and D equals method A minus method B. For the assumption, you assume independence and normality, and SRS is always given or stated. The type of test is a paired t-test, and the equation is the mean minus 0 of the standard deviation over the number of terms. So your t will equal 0.29 minus 0 over 0.63 over the square root of 10. And then you will get 0.29 over 0.199, which will equal 1.457. So your degree of freedom is 10 minus 1, which equals 9. So the probability that t is equal to 1.457 is between 0.05 and 0.1. So we would fail to reject the hoe. We would fail to reject the whole of the difference in the mean amount of E. coli bacteria detected by the two methods for this type of beef because our p-value is between 0.05 and 0.1 and our alpha value is 0.05. And that is the AP question in the Quideo number 5.